Hi folks, yeah, welcome back to the brand new session of electronics circuits, theoretical concepts. Alright, so here, this is one of our fundamental, and it will go through the higher advanced level circuit analysis concepts are discussed here. So you guys will see something like I have divided here in 4 sections, that is resistive circuits, dynamic circuits, and sinusoidal steady state circuits. Have like circuits having the sinusoidal steady state, and there are circuits having like dynamic two-port elements. All right, so in resistive section or resistive circuits, so what we do is like we discuss something about like lump circuits, voltages, currents, power, the fundamental concepts. All right, and here you have like reference directions, Kirchhoff's law, linear and non-linear resistors, whereas diodes. We will not be discussing more in depth about diodes, but we'll be discussing something like independent sources, series and parallel connection of resistive one-port elements, right? So two-port and multi-port elements, dependent sources, ideal transformers, ideal operation amplifiers, analysis of resistive circuits, like this. The analysis of resistive circuits includes some concepts like nodal analysis and its variance, whereas you guys also have some network theorems or this network tools like it's called substitution, Thevenin, Norton, superposition, right? So analysis of circuits with even ideal diodes will be done, but it depends on the situation. If I have like time, I will be doing also about like dealing or discussing about these ideal diodes. All right, so in the second section, that is circuits with dynamic elements, and these dynamic elements are inductor and conductor, like capacitors. Okay, this will be discussed here, and all the representation of series and parallel connection of inductor and capacitor will also be focused here. And then you have like first order RC and RL circuits. C stands for capacitor and L stands for inductors, right? And analysis by inspection under piecewise constant excitation is also done here. You guys have also like general dynamic circuits, second order circuits, and transient analysis of higher order circuits, okay, using the Laplace transformation. And network functions like impedance, admittance, and transfer functions will be done here. So natural frequencies and stability, the connection between frequency domain and the time domain responses will be done here. So extension of network theorems to dynamic circuits will be performed there. And lastly, we have the circuits with sinusoidal steady state. These circuits, the equation of this sinusoidal steady states, the symbolic analysis, phasors, body plots will be done here, and power in sinusoidal steady state, the resonance circuits, power matching. Okay, they will be the exercises will be solved here, okay, for this kind of circuits. And lastly, we guys have the you guys will have dynamic two-port elements, which include the characterization and connection of two-port elements, the coupled inductors and loaded two-port elements, reciprocity, etc. Right? And the ultimate goal of our session will be just to make sure that you guys have the ability to analyze the electric circuits, okay, choosing the most convenient techniques. So all the techniques, among all the techniques that you are provided here, you guys will be able to solve or analyze this any kind of circuits that will be that you will encounter, okay, in your study life. All right, so that's it. And about the introduction part, so and let me begin for like chapter 1, which is all consists of fundamental laws. And let's start exercise number the situation is like you have to compute the unknown currents in the circuit. So what are the unknown currents? There are two kind of unknown currents. That is, one is here, that is I1, and the second one is here, that is I2. So guys, before I haven't discussed any kind of techniques for you guys. Alright, so the basic here I have given is like difficulty is null. There's no difficulty. It's a simple exercise. Whereas the keywords that you is to solve this exercise is KCL. That means Kirchhoff's current law. And for your kind information, guys, what is Kirchhoff's current law? Okay, Kirchhoff's current law states that all the current coming inside a junction or a node, this is a junction. Okay, so you guys check out first the junction. This is a junction, another junction. This can be the another junction. So we have almost like 3 important junctions, right? And it states that all the current that is coming inside a junction is equal to a current that is going out of the junction. So it's like the direction of the current flow in the junction is equals to current flow out, flow in. Okay, is equals to flow out inside the junction. Okay, so this is a Kirchhoff's current law. Okay, so we have situations like we have to find these unknown currents, right? So I2 is one of the unknowns and I1 is one of the unknowns. So for I1, the current is going out in this direction. Okay, so also we can, but for I1 we have 2 unknowns here, right? So if you take out this junction, then we have like 2 like one unknown that is coming in and one unknown that is coming out. Alright, so I think this is not a right junction to start out with. Whereas if you check out this particular junction, okay, first like we find out the junction. So there were 3 junctions. Okay, this one is useless junction because these 2 are totally not available. Okay, the currents are not available here. Whereas this one has 2 unknowns. That is one unknown that is I1 and second unknown that is I2. And right now the third junction, the only junction that is left is this one, and it has 3 knowns and 1 unknown. So we can solve this circuit and get the value of I2, and correspondingly after getting the value of I2 we solve this junction and get the value of I1, and that's the particular idea. Alright, so it's very simple. And I also have stated the circuits here. For the solution is provided here. Apply Kirchhoff's law of current to the node A and B. So that is first A, as I have told you, and then B. That's shown in the figure. By imposing that, the current entering and retiring in a node are equal. So this is a very simple fundamental circuit that you guys solved right now. So after that, let's start exercise number 2. And in exercise number 2 also you guys have to compute the unknowns current in the circuit. Alright, so similarly as above, you guys have the keyword is KCL, that is Kirchhoff's current law. So the unknowns are these 2 unknowns, that are I2 and I1, and we use the same technique first in this junction and then similarly to this junction, right? So it's a very just addition and subtraction is used here. Simple operation. And node A and then node B. Alright, so this is simple for you guys. Okay, so right now here is our third exercise. It says that compute the unknown currents in the circuit. So what can be the unknown? So the unknowns are here, 2 unknowns, that are I1 and I2. And this time the circuit is a very complex circuit, right? Because here you already have a loop and you have some kind of weirdness. This is not provided. This like current and this junction is not like this side is not provided, whereas the unknowns is this one and this 2. So the second one is this one. So what is the basic technique? So whenever you find such kind of circuits, you try to see the junctions. So when you try to find out the junctions, so for the basic idea for finding currents is always to look after a junction. That is the first fundamental key concept. Okay, so let's find out the junction. So for this one also it's impossible because one is unknown here. For this one we have like two unknown, that is one here to need to find, and this is totally unknown. Also this one is impossible, and this one. So overall all the junctions are not provided, like impossible. But there is one particular concept in this kind of circuits, that is you guys can check or see the whole as a loop itself. Okay, because this is a loop, that means one whole junction. Okay, this can be taken as one whole junction, right? And then we, after taking this as a junction, what we see is that like only these four sides are just taken into consideration, and we have only considering these four sides, like we just have only one unknowns. Okay, given this all the three information, so we solve this circuit for this junction as a whole. And then secondly, for this I2, what is done is like you guys have to just grab another situation, like you guys can do anything, like you guys can say that I2 and okay, for this particular solution, okay, you guys can take this situation, that is guys can take this one as a one junction, and it feels like this one, this one, this one, and this one can be found, right? So can be like taken, this one can be taken as a one junction, right? Because this is provided, and this is provided, whereas this is the unknown. So we solve this particular junction and solve it. But I have also, like, there are so many, it's not that you can have only this possibility. Okay, you guys can have multiple possibility to solve the exercise. Like, it's not required that you can also just like have to follow this only one method or one technique. Okay, you can follow or check out so many other steps or procedure. All right. So as I have described here, we apply KCL, that is Kirchhoff's current law, and as I have described here, like for junction A as a whole, you have taken, and if you are going to solve, and you get the information about I1, and lastly for junction this one, that is B, we just try to solve for I2. Alright. Okay, so right now let's go to exercise number 4 then. So in exercise number 4, what we have to do is like compute the unknown currents in the circuit. So let's find out the unknowns first. The unknowns are I1 at this side, I2 at this side, I3 at this side, and I4 at this side. So if you check out this junction, two unknowns are here, so it's not a feasible solution, not a right solution, like not a appropriate solution. So we need to find at least, like in a junction, like at least 3 knowns and only one unknown, so that we can solve the exercise, right? And also here in this junction there are 2 unknowns, and lastly also in this junction there are this one and this one, these 2 unknowns. And lastly for this situation, yeah, in this junction we have 2 unknowns and 1 unknown. Also this can be taken, alright, or you guys can also take I think this is one of the possible solution that you guys can start up with. So you start or you guys can begin with this junction, okay, driving the information of I2, solving for the information for I2. Then after getting the information of I2, you guys can take this junction, knowing these two knowns, we solve for I4. Then having the value for I4, you guys can solve for I3, knowing two unknowns. Then after knowing the value of I3, you guys can solve for I1, knowing I3, right? Because the other side is given. And this is the procedure how you guys should follow. Okay, this was one of the possibility. Okay, but there is also another possibility that is stated in the solution, that is you take the whole as a junction. Alright, also this was one possibility, right? Because the whole is taken as a junction, knowing only I1 is unknown, and knowing I1 you guys can like solve for I3. Then knowing I3 you guys can solve for this I4. Then knowing I4 you guys can solve for I2, and that's it. It's a very simplistic solution, right? As I told you guys, like there can be like numerous possibility of solutions, okay? Not like you guys have just to follow the same procedure that is stated here. You guys can find out yourself. It's just like the logic, okay? You guys have to find it out by yourself, just using the appropriate technique, okay? The technique is always KCL, and the rule must follow, that is current flow in must be current flow out must be equal to current flow out, right? And this was it for this exercise, and the solution is given here. Alright, so with that, let's begin exercise number 1.5 then. And this fifth exercise, what we have to do is like compute the unknown voltage in the circuit. So okay, so before going to the exercise, I would like to just state some information about KVL. What is KVL? KVL is a Kirchhoff's voltage law, and states that the sum of voltages inside a loop is equals to 0. That means you guys have to always understand the sum of voltages in a loop means, or a mesh means, like the voltage must have a same direction. Okay, so you guys have to follow through the same direction. Like you guys have to take the same direction here. Alright, and with this direction you guys can just find out the appropriate voltage and with the condition. Alright, so what are the unknown voltages? The unknown voltages, there are so many multiple unknown voltages. There are like there's a V1 here, there's V2 here, okay, in the same loop or same mesh, whereas there is a V3 here and V2 here in the same loop. And okay, we have V2 here, but we have two given here, like these two voltages are given. Alright, so what can be done is either you guys can solve for V2 inside this loop. Then after knowing the value of V2, you guys can solve for V1 inside this second loop. And lastly, after knowing this value of V1, you guys solve for this particular loop. Okay, actually the loop direction can be taken anywhere, like clockwise or anti-clockwise, but it depends on the minus or plus sign that you guys use. For example, if you guys destined to use clockwise direction or clockwise loop, then you guys have to always follow this direction. Like for example, let me show you, like if you guys are following clockwise direction, then this will be positive, or similarly this V2 will be positive, and also this 2 volt, this one will be positive, so all this will be positive. Alright, But if you guys follow in this clockwise direction, then this V1 will be positive, 3 volt will be positive, but this one will be negative. Alright, and also similarly this V2 will be negative. So this is the some fundamental concept. Okay, solving for V2 we will get something like, I think, minus 4, yes, and solving for second one is this one. Solving for V1 we will get minus 4 here, that will turn positive, so minus 4, minus 1, minus 5, and this one will be positive, so minus 5, positive 3, minus 2, and it will okay, so the solution is provided here, minus 2 and this is minus 4. This will turn to positive, positive, minus 1, minus 1, 3 minus 1 plus 4. It's like 7 minus 1 is 6 in a negative direction. Alright, so this is some simple addition. Okay, after knowing the trick, you just add and solve it. And similarly with this one, we also use the same technique and the same loop. And it's convenient for you guys if you guys specify the direction that you are using. For example, the direction here I am using is a clockwise direction, and I have specified like by this dotted arrow, whereas for this one I am using my anti-clockwise direction, and for this one I am using dotted arrow similarly. Alright guys, so that's it, and here's the particular solution for this one. Now for exercise 6, also here we have to find the unknown voltages in the circuit. And first step, let's find out what are the unknown voltages, and this is the first one, and W is the first one, this one Vx is the second one, Y is the third one, and Vz is the fourth one. So we have 4 unknowns here. And similarly we also use the same technique, that is let's take this loop first, and after knowing this information, so you guys can also follow through.
Quindi il G. C'è un mio compagno di a Patolò, sempre presente. Non vedi come lo uso? Facciamo il G.
Yeah, that is the first one. We find VW. After finding VW, what can be the second step? The second step, you guys can like go through. Yes, this one. You can find V3 going through this loop, this partition loop. Okay, because there's 2 are unknowns and this one is unknown, that is VZ. After finding VZ, you guys go through this second loop and go to find VY. So at this point you guys have found VW, and secondly you find VZ, and thirdly you find VY. After knowing VY, you guys find VX, going through this particular loop. Alright, so loop 1, loop 2, loop 3, and this one is loop 4. Alright, and that's it, and a simple addition and subtraction. So here I have described the mesh, particularly like the junction is noted, that is F, C, E, F. Alright, go through this situation here. For VW we find 0, for VY we find -2, for VZ we find 4 volt, whereas lastly for VX we find -1 volt. Okay, now guys, let's begin exercise number 7. So here what you guys have to do is like use the Kirchhoff's current law to compute just I1 and I2. So here for finding I1 and I2 is stated. So what can be the technique here? You guys can use a technique that is,
Cioè, tutto questo però deve essere anche di
yes,
Esatto,
that can
quindi
be something like,
questo, e guardi
vedi
se-
qua il minore.
Esatto.
yes, that can be something like, you guys can take this junction, provided that the current flowing through this junction can be found, right? So that is also similar with this current. So the current coming here will be equals to current going out through this line and this line. Alright, so and these two are knowns, so we find this unknown. After knowing this unknown, we take this one, this hole as a junction. Alright, so after taking this hole as a junction, we find this particular unknown, that is I2. Alright, so this is one of the simplest example. Alright, so you guys can check out it. I1 and we go through the junction A, then we go through junction node B. So yeah, there can be so many solutions. So you guys can go through any kind of there is not only one special solution. There can be a multiple solutions. Okay, you guys can choose to use any kind of method just to solve the exercise, and you guys can end up with lastly you guys end up with the same result. Alright, so and similarly before I use this technique, this can be also used, and the solution stays this technique also, this can be used. Also the same current flows through even through this source. This is a voltage source. Okay. Okay, so now let's begin exercise number 8, and in this exercise what you have to find is again the unknown currents. Okay, and these unknown currents are respectively I3 and I5. So what can be done here? I can particularly see the junctions here, this one, junctions here, this one, right? So given the information that about I4, the value of I4 is given and I6 is given here. Alright, and after knowing the information of I4 here and the value of I4, okay, but here is another junction here, so the value of I1 is also given here, right? So and I2 is given here, so the idea is like immediately we guys can use this junction because there are two knowns here, I1 and I2, so we find I3 respectively using this junction, and then after finding this junction, the value for I3, you will go to you guys can take this as a whole as a junction. Alright, so after taking this as a whole as a junction, you guys can take these four sides that are I6, I1, I4 and I3. Alright, so as you guys know that I6 and I1 are given and I4 is given, you can like easily find I5, right? Using the simple technique of KCL, is flow in equals to flow out. And that's also the same thing is done here. A and then B. You guys can tell, look, first I did B, then A. Here it's done A and B. It's okay. You guys can follow any, start with any node. Okay, so for exercise number 9, here what you guys have to find is like B1, BAD and BC. A, D and BC. Okay, so I have to notify or give a very special trick or remark, okay, to be noted is whenever you guys encounter such kind of voltages, that is VAD, that means always be careful that the direction of the voltage will be going from D to A. That means the direction will be some like going from in this direction. Alright, so this is from D to A direction, and this is positive. And also for VBC, the direction will be something like from C to B. Okay, so you guys can draw an arrow as a reference, arrow here, like from here to here as an arrow. Alright, so after this basic remark, you guys can start solving, and if you start solving, you guys can easily find VAD because take this loop, because the two voltages are known here, and after that you guys can find V1. V1 is here. So for V1, what you guys can take is a whole loop. Okay, there is an inner loop. You guys can take inner loop and also an outer loop. And for outer loop, this bigger loop, you guys have, this is given, this one is given, and this one is given. Three are given, three voltages are given, and this one is unknown, so we just similarly solve this exercise. And lastly, we take this whole loop, that is first draw the reference voltage here, that is the voltage that need to be found, that is VBC, and similarly we take this loop and solve it easily, knowing V1, this EA and ED. Alright, and lastly we find this. And just be careful about the direction. And that's it, right? TAF. Here you can see TAF. Okay, so here what is done is like we take from D, A, F. Also this can be done anywhere. You guys can have multiple solutions for this exercise. Alright. And similarly after finding V1, here what he has done is for VAD, just using VAE plus VED. VE plus
nel senso che è diventata 4 z quadro
ED.
lo so, però là sono viene meno un metro.
And that's the way to solve for this exercise, alright? So lastly for BBC, the BBC we have 4 volts. Alright, so that's it. Okay, now let's begin exercise number 10. And this exercise number 10, what you guys have to do is like you guys have to use the KCL and KVL combined, and you have to find like the unknown currents and unknown voltages. So respective currents like I1, here I can see I1 here first, I2 I can see here the unknowns, and VAD, that is like this voltage that is starting from here, and VX, that is this voltage. Okay. And similarly we use the technique that we use is please, it can be, it depends on the situation.
Questa condizione non ce la frega un cazzo.
It can be done.
No, perché non si verifica mai.
Okay, I got the technique. The technique is this node or junction can be used because there are this current I1, this is the only unknown here, and there are two knowns. There are 3 ampere, and this one, the current from here, that is I88 is here. Alright, so here it is done here. By solving this junction we find I1. So after finding I1, what you guys have to do is like you guys can take this junction as a whole, and you can solve for I2 knowing I1. Alright, And then for voltage, that is VAD, that means like the direction is from D to A, right? So for VAD, you guys can go through this loop, that is this loop, and knowing 20 volt this voltage source, minus 5 volt this voltage, and 8 volt, you can solve this loop and find VAD. Whereas similarly, you guys can find Vx by going through this loop, that is 8 volt is provided here, VAD will be solved and provided, and this 3 volt is provided here, and similarly solve this. Alright, and that's the way it is done also here. To calculate value of I1, we apply KCL at node C and A. C and A. And for finding voltage, we mix A, E, B, D. So is A, E, B, D. This means, and similarly, mesh 2, that is C, A, D, B, that is C, A, D, and B. So this kind of mesh is used. And here's a particular solution. So lastly, we found VAD will be 7 volt, Vx will be 12 volt, whereas respectively I1 will be 5 ampere and I2 will be 2 ampere. Alright. Okay, now let's begin exercise number 11 then. So guys, what you have to do here is like compute the power absorbed by each circuit element. As you guys already know that power is something that is an ability of doing work. Okay, it's like a capacity of doing work, or the ability of doing work. So and for power, you guys can, there's a simple expression to find the power, that is current multiplied with voltage. That's a product of current and voltage gives you the power. So and what you guys have to do here is like you have to find the power, and for each circuit elements, that is noted by specified by B1, B2, B3, B4. So just guys find for respective circuit elements the current passing through it and the voltage passing through it. So after knowing this current passing through it and the voltage passing through it in each circuit element, you guys will be able to find the power. So and that's it. Okay, before going the exercise, let me go through the technique. And for B1, current is known but voltage is unknown. Alright, and what can be done? The thing that can be done is I can see the current here in this junction. If you check out in this junction, the two like you guys have two known currents, that is 2 ampere and 3 ampere, that are known currents. There is one unknown current. So this unknown current can be found by using KCL here in this junction. And after knowing the current here, the voltage is already known here, so immediately you find the power here. Alright, so after finding the power here, the second step is what you guys can also do is like you guys know the voltage here, right? So this voltage will be same with this voltage, you guys can see, because if you check out the loop here, okay, if you use a KVL loop here, you guys can see that in this loop there are just two elements. Alright, so this loop's condition satisfies, and this voltage will be same with this voltage, and after knowing the voltage you already know the current and you find the power respectively here. Alright, now knowing this voltage, you guys can also know the voltage of V1, because this voltage is already given, and now we use second loop here, second piece here, and then immediately you find the voltage here. After finding the voltage, the current is already known here, and immediately you find the power here. Now for the last element, this one, what you guys can find is like you guys can use like something like okay,
secondo me
what you guys can find is like the current
abbiamo
is
integrato in
going
pratica
through this
come se
direction,
fosse un po' invece che
and
magari non si rischia.
what it's doing is the current is actually flowing through
Qua
this
non puoi
direction.
mettere la Z qui.
Okay, because the current flows in the opposite direction to the direction where the voltage flows.
Devi sempre
Okay, voltage
a fare il disegno e vai a
so
prendere il valore.
the direction will be here because this is the element. This is the fundamental concept for you guys to understand. That is always the voltage, the direction of the voltage will be opposite to the current flow. So the current flow, the direction will flow from up to down here, whereas the voltage going from down to up. So in this situation, this will be a negative of this current, that is positive to A, this will be negative to A, and knowing this current you will find respective this here.
Un'altra cosa.
And yes. And similar is done here.
No, per parallele la
P for power of 4, negative 2 current. Whenever negative 2 ampere current is used here. Alright, and similarly, as I have stated, all the respective voltages are found with this similar technique here. Alright, so you guys can check out the you guys can check out the power, the result here for circuit element 1, you have power minus 4 watt, and for particular information, power can be also negative.
Tu che hai fatto scemo.
Sì, tu.
Scemo t'ho seguito.
Power 2, you guys can also minus 4 watt. Alright, so let's begin the exercise
Che sembrava sapesse cosa faceva.
number 12 then. And here the battery, this battery P is given, and what it supplies is like 100 watt of power is supplied here, and the voltage here is 100
Chiamalo
volt.
Valerie così.
So, and what you guys have to complete is like the voltage, this unknown voltage V, and unknown current I, and the power absorbed by the device V1. So what can be the technique here? You guys can see the technique can be
Esatto,
the only one that is
bisogna capire cosa cambia.
power is given here, and the voltage is given. So using the expression of power, we can find the current here, knowing the current here. Okay. So knowing the current here, we can respectively use the same current here because it's the same current flowing through, but in a opposite direction, right? And then knowing the current here, you guys can find the voltage here. I mean the voltage here, yeah. And knowing the voltage here,
Coordinate easy che lo so, mi coordinate
here, but this current will be same and to be flowing through here and going through this. Like current will be also same, and we have the current will be something like same as I. And now knowing the current, the voltage unknown, so to find the voltage we use the mesh in this whole circuit, like as a whole we take the mesh, and then this is known voltage known, this is the known voltage, this is known voltage, knowing the information of resistor and current, V equals to IR using Ohm's law, right? And we use this. We also find this particular voltage here. And that's it. That's it how we use it. And
Adesso andiamo avanti. Le grani su K.
that's the same way it is done here. Okay, so you guys have here like 1 ampere current that is flowing here, and what can be the situation like? Is a minus.
Che tipo di tromba? Stai scherzando? È buonissimo.
Stai scherzando?
Meno pari con i dadi. Al giorno fa due. I migliori sono quelli che ripetono lo stesso. Al giorno fa due. Finca tutto.
Okay, the voltage will be something like voltage will flow in here. Voltage will flow in here. That is positive. This will be negative voltage, right? And similarly, this will be also a negative voltage, and also similarly like this. Alright, so if you guys solve this circuit as I have told you, you guys will find the solution, and the solution is stated here down below. Lastly, you find a power that will be 20 watt for this circuit element B1. Okay, so lastly we have a last exercise, and in this exercise you guys have to just find the power absorbed by each circuit element. So what I mean by this each circuit elements is like this one as a resistor also. You need to find the power in this resistor. It's also for this current source, whereas also for this second resistor and this voltage source. So what can be the idea? The idea can be something like as you know the current, you guys will also know the voltage here. As you know the voltage here, because using the symbol ohms law, equals to IR here. As you know the voltage here, you know the current here, you know you have the resistor here.
Non insieme all'inizio.
No, non finito dopo. Cosa canzone?
Okay, so after that, what can be done? The situation that can be done is like this voltage, this current will be divided here and here, right? So while the current is divided here, you guys can check that this is the voltage here. So what else can be done? Okay, the thing that can be done is you guys can use the loop, same loop, that is a mesh here. So using the mesh, you guys can find out the voltage here. You guys will know the voltage here, because this voltage will be same as this voltage, right? Alright, so after knowing the voltage here, you know the current here. So knowing the current here, you guys will also know the voltage here and the current here. So respectively, also the current here will be also known, because the current will be the division of this current and this current. Like current flow here will be divided into here, this and this. Knowing the current here, like we use a simple arithmetic and find this current here. Alright, so that's the way here. So for each element you guys can find the voltage and current respectively. So after finding the voltage here, you guys can also find the voltage here using the mesh loop here. Alright, so this is the simple technique that can be used, and the power can be found. So similar technique is used here. Alright, so you guys can check out here. For I1, I divide the voltage by the resistor, right? You can check out the voltage is same as 4 volt using the loop. Also find I2, that is division from this current that will be flowing, that will be something like 3 minus this current will be this current, right? And lastly for voltage will be this voltage will be the current into the resistor, whereas and lastly for V2 we will use the KVL, and same flows here, and you guys have the lastly the power, that is also the product of current and voltage. Alright guys, so that's it for the fundamental concept of circuit theory. Alright, and this is one of the most fundamental and basic concept where we discuss about KCL, KVL and some other basic fundamental concept that is very useful for circuit analysis, and concept about or some more technique which is used for